we are not taking test today because we have a small portion of reactivity series left. We will complete it and then we'll start. So, Sanim, আমরা যেটা বলতেছিলাম দেখো, potassium reactivity series, if I just recall a bit, potassium, sodium, lithium, these three metals, these are where? Group 1, right? Group 1. Right? As we go down the group, reactivity of the metals increases. To me, say lithium metal, you will put in water, it will react vigorously. But if you put francium, then the world will be destroyed. It's something like that, right? So as you go down the group, reactivity increases. So if you put lithium, say for example, take water in this are you prepared for the test? Yes. Okay, but we are not taking test today. Sit down. এখানে বসো, সামনে বসো. Right. So say for example, we are taking small say 100 cm cube of water or some water in this. What is this? Do you know? Conical plant. Shahir, you know, right? Very good. What is this? Big brother is big brother always, right? Measuring cylinder. It's a measuring cylinder. We'll discuss these stuffs in detail. And what is this? Do you know? It's a volumetric flask. We'll give you the uses. Shopgular use আছে. Separate users. Moreover, what you need to understand is chemistry lab is nothing but a kitchen. বাসায় তুমি কিচেনে তুমি চামচ দিয়ে হচ্ছে স্টার্ট করো, স্পুন দিয়ে। Chemistry lab we have glass rod. The same thing. For starting we use starter, মানে glass rod, right? Spoon দিয়ে তুমি ধরো you transfer say sugar or milk, right? Spoon দিয়ে আমরা we transfer salt. আমাদের স্পুনের নাম কি? Spatula. So that is the difference. It is say for example এটা এমন কেন? Because এখানে যদি আমি কিছু নিয়ে swirl করি, if I swirl, then it will not fall down, right? It will not spill out. So that's why the shape is like this, right? So measuring cylinder, by its very name, you can see there are many calibrations. So if you want say 40 cm cube of water to take, not exact 40 cm cube, but very approximate, then you can use this measuring cylinder, right? So we have different uses for this. যেটা আমি বলতেছিলাম reactivity series, আমি হচ্ছে এখানে কি করলাম, I took some water, I put lithium. লিথিয়াম পুট করার দেওয়ার পর তুমি কি করবা, দেওয়ার সাথে সাথে তুমি একটু your মানে your কি বলে expression will be like this. If you put potassium, expression will change. Sorry, sodium, lithium then sodium. You will see fire on water. Sodium metal will move around and it will float on, and you will see a piece of fire is going on, right? So if you add small amount, but if you add in big amount, আমাদের ল্যাবে একবার একটা স্টুডেন্ট কেমনে যেন পাইছে সোডিয়াম মেটাল, বলছে এত বড় একটা পিস সোডিয়াম মেটাল কি এর কিসের মধ্যে যেন দিছে, পুরো স্কুলে হচ্ছে ধোয়া হয়ে গেছে, পরে সব স্টুডেন্ট বের করা লাগছে, পরে ফায়ার ব্রিগেড আসছে এসে ওটাকে করছে. Do you get my point? So sodium is more reactive than lithium. Now if you put potassium, you will see flame on fire, and if you give in big amount, then you will run away. Rubidium, rubidium we don't use in our lab naturally because you can see how vigorous the reaction will be. Cesium, 1 gram, some hundreds of dollars. Cesium, it's not radioactive, but it will burst. A very small amount with water will burst. Now you see, if you give small amount in water, then it's a vigorous reaction. If you put in acid, then what will happen? Very dangerous, right? And francium is radioactive. So francium, even I didn't ever see how francium works, but cesium I saw in video, and you can see later on. I'll show you how the reaction will be done. But you see, as you go down the group, reactivity increases. So how the reactivity series is made, just like this. It's not something we will memorize. Rather, since this periodic table will be given in the exam hall, then we can easily write it down. We can write it down. So you see, I'm writing francium, then cesium, then rubidium, then potassium, then sodium, then lithium. But in the reactivity series, you see, we don't have these three. We have only potassium, sodium, lithium. Why? Because these three can be used in the lab, school lab. That's why we put, right. We just put this potassium, sodium, and lithium in the top of your reactivity series. Do you have? Where is your book? Oh, you need a pen. I have lots of pens in this box, but need to check whether it works or not. What? Okay, very good. You don't need to write anything. It's written. Periodic table. Okay? Take in your random access memory. Not in your hard disk. You don't need to memorize. It's given, and in the example it will be given. Okay, so francium. These are all what? Group 1. Now, from group 2, again, same thing. Barium we don't use because it's very poisonous. That's why we don't use in the lab. But as you go down the group, reactivity increases. So after lithium, what will be the next one? Can you tell me? Ra, right? Radium. Radium is most reactive in group 2. Then what you say? Barium. Right? Then what? Strontium. Sr. Then Ca, calcium. Then magnesium. So these are all group 2. Do you get my point? Huh? So reactivity series is not something you will memorize. If you look at the periodic table, you will understand how to write it. You can make your own reactivity series. Okay? So put them in water. All these metals, take you have 3 and 3, 6, and 3 and 2, 5, 6 and 5, 11. You take 11 beakers and put same amount of these 11 metals. From the reactivity, you can arrange them in the reactivity, right? And I said already, right, how it works, right? You'll see this one will react. You cannot imagine how vigorous the reaction will be. And magnesium, you will find almost no reaction with water, almost no reaction. Some bubbles will come out, right? And then aluminium, group 3, transition metal we will not discuss now. From the transition, group 3 metals, which is 13 basically, it's written here. They do 13. So see, you have the metal aluminium, right? Then gallium, then indium. That's how it goes. But which one you know? Aluminium only, right? So I'm not bothering you. Just I'm writing aluminium. Group 3, right? Then we have what after aluminium? So I'm basically erasing some stuff. Francium, cesium, rubidium, we are not taking, and radium, barium, strontium is not there. So this is how it goes. Right? I've made it short, but how it came, I just explained. Right? So aluminium. Then what? You see the reactivity series. You have carbon as a benchmark. Why we put carbon, even if it is a non-metal? We'll explain later on. When we'll extract metal, this carbon, this graphite, or a barbecue, barbecue যখন করো, this is the fuel, black carbon, কয়লা যেটাকে বলো তোমরা, barbecue বানানোর সময় এটা ইউজ করো, এটা হচ্ছে carbon, or pencil lead তুমি ইউজ করো. So it's a very good fuel. Why we are putting it? We'll explain. And we have explained a bit. Any metal which is above carbon in the reactivity series, they must be extracted by using electrolysis. They must be extracted using electrolysis. All these metals, right? Any metals which is below carbon, you can extract by other means, cheap method. Okay? So, any metal গুলোর দাম কিন্তু অনেক বেশি because you need to go for electrolysis. Any metal which is below carbon, এগুলোর দাম একটু কম, less costly. Fine? Because cheap method use করে এটা তুমি you can extract. We will discuss that later. Right. So what I am saying is this is how reactivity is done. Then some transition metals will come. Say after carbon you have zinc, then iron, and in some books you will find lead. Then what will come? Hydrogen. Then 3 jewelries will come. We have discussed copper, silver, and gold. It's written in your book in the first page. Whatever I have written. So these 2 are transition metals. Then hydrogen again a non-metal, is a benchmark. Hydrogen is the benchmark. Carbon is a benchmark. Hydrogen is a benchmark. Hydrogen, why we put? We have already explained in electrolysis chapter. If you are not present, but it's explained. Now we need to see how the reactivity will go on. So let's see. আমরা তিনটা জিনিস দিয়ে এটা দেখব স্পেশাল 3 things. Let me write it in. So first 3 Ayman, Salim, can you tell me what is the first metal in the reactivity series? Potassium, then sodium, then lithium. These are group 1. Then calcium. First calcium. Calcium is down. Calcium, then magnesium, right?
Yes.
Okay. Now what? Carbon, right? Or aluminium is there. Aluminium, group 3. So this one is group 1, then group 2. This one is group 3. Then we have carbon. Then after carbon we have zinc, iron. In some book you will find lead.
Oh, lead.
Lead you will find in some books. And hydrogen.
The metals.
Then jewelries. Copper, silver, and gold. Right? So this is what you have in your IGCSE O levels, right? Copper, silver, gold is serially written, as I say. C. Cu, Ag, Ag, serial. And all these 3 metals are used in gold, making gold, making jewelry. Okay? Why? Because they are very unreactive. Okay? So they will be shiny. They will not react, so they will be shiny. They will remain shiny. Right? And gold is most unreactive. That's why you can keep gold at your home or in jewelry for even hundreds and thousands of years. Right? Any question up to this? Now we want to check the reactivity of all these metals with 3 things. 3 things. Hang on. 3 things, Kiki? What are the 3 things? Cold water, liquid water. Then water, steam, gaseous water, steam দিব ওদের আরেকটা কি অ্যাসিড দিব অ্যাসিড তাইলে which one is safest you think to add? Say for example you don't know the reactivity of a particular metal. You are in a lab, you have metals. In which test you will do first? Will you put in acid or in steam or cold water? Steam. What? Steam is, what do you think? Steam is very dangerous. Steam is more dangerous or liquid water is more dangerous? Steam is dangerous. It can burn because it has more energy. Right? It has more energy. It has more kinetic energy. So if something reacts vigorously with cold water, it will react even vigorously with steam. You get my point? And acid you understand, right? Acid is even more dangerous. It has more strength and power, right? That's why for all these metals, 6, these 2 are non-metals, so we are not using them, right? They are just benchmark. Okay? Now, for all these metals, we have 6 here, group 1, group 2, group 3. Then we have zinc, iron, lead. Then we have copper, silver, gold, right? For all these, 6 and 3, 9 and 3, 12. We'll take 12 beaker and we'll put water, say 100 cm of water in all these beakers, and we'll take same amount of potassium to gold and we'll put them and we'll check how it reacts, right? So what will happen if you add water, potassium plus liquid water? What will happen? It will form potassium hydroxide and you will see hydrogen gases coming out. Metal hydroxide. Always, if you add cold water, metal hydroxide and hydrogen gas will come out. Same, sodium hydroxide and hydrogen gas, lithium hydroxide and hydrogen gas, calcium hydroxide and hydrogen gas, magnesium hydroxide and hydrogen gas, and it will stop. No other thing will react. For magnesium, with calcium, you see flame on fire, fire on water. You will see fire on the ice, fire on the water, right? So you'll see flame. Potassium, very reactive metal, so it will give you flame. Why? Group 1 chemistry will discuss. Fire water, that will discuss, and lilac color flame you will see. We'll discuss that later on as well. So it will give you the most vigorous reaction, and you will see within a fraction of a second, within 1 second, the reaction will be finished, done, complete, and all the hydrogen gas will be bubbled up immediately. Before you can write any observation, the reaction will be done. Sodium, a bit less vigorous. Lithium, even less vigorous. Calcium, you need to wait for 10 minutes in order to find your bubbles. Hydrogen gas will bubble up, right? So you will see bubbles are coming out. So you need to wait for 10 minutes for hydrogen gas. For magnesium, initially you will see some bubbles, then the reaction will stop. So from the observation, you can easily say potassium is most reactive and magnesium is least reactive, and all other metals you will not see any bubbles. Means you can say with cold water, aluminium to gold is not reacting at all. Is it clear to everyone online? Online?
Yes, sir.
Do you understand?
Yes, sir.
Yes.
Okay, thank you. আজকে টেস্ট নিব দেখে স্টুডেন্ট নাই না সবাই তো জানেন টেস্ট নিব স্টুডেন্ট নাই
আর ইনপুট আরেকটা স্কিল চলে গেল
কে
ইফতিখার
ইফতেখার
বললো যে কোথায় যাই যাবে
আচ্ছা আচ্ছা very good.
লাস্ট ম্যাথ ক্লাস was
We'll see them inshallah.
and has really good.
Okay, so what you need to understand is cold water এর সাথে যদি কেউ react করে, they will give you metal hydroxide and hydrogen gas. That's it. So you can write metal plus cold water, metal hydroxide and hydrogen gas, and it's written in your book as well. You see page number 150 and underline. Metal plus cold water, metal hydroxide and hydrogen gas is underlined. 150 page. Did you get it?
Yeah.
The beginning. See, metal plus cold water, metal hydroxide and hydrogen. You can underline. You can write it later. It's written in your book. Oh, it's written. 150. See, metal plus cold water, metal hydroxide and hydrogen. That's how it goes. Right? Calcium hydroxide and hydrogen. And magnesium. Magnesium is not, we didn't start it yet, but it's up to this.
এই গ্যাসের তো এরকম হবে না কারণ এটা তো সলিউশন ফর্ম করে না
কোনটা?
গ্যাস
হ্যাঁ গ্যাসের ওটা আমরা তো বলি না এখন we are coming right okay hopefully everyone understood. Now these things will not react right now. So we have understood the reactivity from potassium to magnesium. Now we want to check whether from zinc to gold how will arrange them in reactivity. So we need a different thing. We need to have something more powerful, what will give and we will analyze, right? Since potassium is reacting very vigorously with cold water, we are not performing this reaction in lab. Why? Because since it is reacting very vigorously with cold water, we are not there to give it in steam. Do you get my point? We are not performing. But if we perform the reaction, it will give you potassium oxide and hydrogen. Sodium oxide and hydrogen. Instead of hydroxide, they will form oxide. Lithium oxide and hydrogen. calcium oxide and hydrogen, magnesium oxide and hydrogen, aluminium oxide and hydrogen, zinc oxide and hydrogen, iron oxide and hydrogen, lead oxide and hydrogen, and these three jewelries are not reactive. Is it difficult? Many reactions, but not difficult. Why? Because these are all metal oxides. So with cold water, they will form metal hydroxide and hydrogen gas. With steam, they will form metal oxide and hydrogen gas. So in your book, they will write the same thing in pages after pages. But this is basically one single thing, one single sentence: metal oxide and hydrogen gas. That's it. Pattern. আমি বলতেছি chemistry is a pattern. তুমি যদি সব করতে যাও sentences by sentences, it is difficult. কি করা লাগবে? প্যাটার্নটা ধরা লাগবে. What is the pattern? ঠিক আছে? আর এগুলাতে তোমাদের প্রবলেম আছে কারণ magnesium hydroxide কেন MgOH2 প্রবলেম আছে? Do you know the spelling rule of this magnesium hydroxide? Why it is MgOH2? Do you know? I don't know. I'll give you a YouTube link. You need to see.
Magnesium has two valencies, so two transfer to that side.
Exactly. Okay, two to be guide koro, but I'll give her my videos, initial videos. She can take. See, Aman, magnesium hydroxide can MgOH2 still problem আছে? Sure. দেখো কিন্তু
1 to 10 সব
হ্যাঁ শুধু 1 আর 2 দেখছো
1 to 10
1 to 10 সব দেখছো is it seriously I'm very happy on you okay so this is how it goes so any question no very good online any question
Sir.
Maisha
No, sir.
right so last thing now আমরা যেটা বললাম যে এগুলো আমরা চাইলে করতে পারি তোমাদের বুকে দেখবা ওরা হচ্ছে ম্যাগনেসিয়াম অক্সাইড থেকে স্টার্ট করছে because the reaction between magnesium hydroxide magnesium and cold water is very slow that's why we have started in your book they started from here but any metal if they react with steam they will give you metal oxide not hydroxide and hydrogen gas is common everywhere right now with acid say for example if we add hydrochloric acid means we are taking 12 beaker containing hydrochloric acid and we are putting all these metals so you should not put potassium metal in hydrochloric acid in the lab because you will run and all other students with you will run and the whole school will be running right and principal will call fire brigade right so that's what will happen there will be burst potassium with hydrochloric acid so you should not do this reaction but if teachers do in a very closed container and very technically if they do it with very small amount of potassium we can do see if we do what will happen potassium chloride it's metal see metal plus acid salt and hydrogen gas potassium chloride and hydrogen then sodium chloride and hydrogen gas then calcium chloride and hydrogen gas then lithium chloride plus hydrogen right calcium chloride then magnesium chloride plus hydrogen gas then aluminium chloride plus hydrogen gas then zinc chloride plus hydrogen gas then iron chloride plus hydrogen gas then lead chloride and hydrogen gas and restore So see, very easy. If you take, instead of hydrochloric acid, if you take sulfuric acid, then potassium sulfate and hydrogen, sodium sulfate and hydrogen, calcium sulfate and hydrogen, magnesium sulfate and hydrogen, aluminum sulfate and hydrogen. Sulfate ion. If you take sulfate ion, then what is happening? Metal plus acid, salt and hydrogen gas. That's it. Metal plus cold water, metal hydroxide and hydrogen. So I'll write it for you, but that is the thing what is going on. But copper, silver, gold is not reacting. And any metal which is below hydrogen in the reactivity series will not react with cold water, neither with hot water, means gaseous water, nor with acid, dilute acids. Right? So they are very unreactive. So even if I wrote many reactions, I wrote how many reactions? Categorically, how many reactions I wrote? 3. So if you know these 3 reactions, you know hundreds of reactions. Right? So that's how we need to go. So in the whole O-levels syllabus, we have only 10 to 15 reactions, not more than that. Only 10 to 15. The whole syllabus contains only 10 to 15 reactions, not more than that. So these are all categories. As I say, metal plus cold water. Metal plus water. Metal plus water. So it's metal hydroxide and hydrogen gas. Metal plus gaseous water means steam. Metal oxide and hydrogen gas. Metal plus acid, salt and hydrogen gas. It's written in your book again in that same page. Metal plus steam, metal oxide and hydrogen. You get it? So in page number 150, the first 2 things is given: metal plus acid and metal oxide plus acid. Metal plus cold water and metal plus steam given. Now for acid, same thing. Metal plus acid, salt and water. 154 page. You see, 154 page. Just write. Write down. Metal plus acid, salt and water. Right? You give sulfuric acid, hydrochloric acid, nitric acid. Any acid you give, you are getting the same thing. Potassium sulfate, sodium sulfate with sulfuric acid. If you give nitric acid, potassium nitrate, sodium nitrate, lithium nitrate, calcium nitrate, and hydrogen gas is always there. Right? So that is how it goes. Any question from online?
No, sir.
No. Thank you. Right. Let's go back. So basically আমরা এই চ্যাপ্টারটা প্রিভিয়াসলি আমরা হাফ কভার করে ফেলছি, redox reactions. So right. So now look at the book. You see, I say this one. This is the number 1, metal plus cold water. So metal hydroxide and hydrogen gas is underlined. If you have the book with you, 150 page. And second, metal plus steam is forming metal oxide and hydrogen. Then you see, they have said already reactions of potassium, sodium, and lithium with cold water. Then reaction with calcium with cold water. So this is slow. So slowly it will produce. So calcium and water, calcium hydroxide and hydrogen gas. Then there is almost no reaction. Some bubbles. If you have very clean magnesium metal, a few bubbles of hydrogen form on it, right? এখানে একটা reason দেয়া আছে. This is because the magnesium becomes coated with insoluble magnesium hydroxide. মানে magnesium hydroxide যেটা form হইতেছে, it is insoluble, and on the metal magnesium hydroxide যেটা form হইতেছে ওটা coat করে ফেলে. So magnesium cannot come in contact with water further, and the reaction stops. Magnesium hydroxide যেটা form হইলো, that will coat the metal, right? that will cover the surface of the metal, and the reaction will stop. That's how it goes. So we'll give you later detail, and you will understand. Then see, if you give steam, first 4 we didn't, the book didn't give, because the reaction is very vigorous. You should not try in the lab, right? So that's why they started from magnesium. See, magnesium metal is here, mineral wool soaked in water, cotton wool is soaked in water, if you look at the diagram, and we are heating, say for example, a test tube, this one, a test tube, or something like this, measuring cylinder, say cotton wool, cotton wool soaked in water. So if I give heat, then from the soaked cotton wool, steam will come and it will react with magnesium. So in the same procedure, you need to do everything, all the experiments, right? So because you need to produce steam, right? So steam will come through the magnesium metal, and we have a cork and a delivery tube. You can put a gas syringe here so that you can see hydrogen gas is coming out, right? Or you can collect it over water, you see, over water, so that you can see the bubbles. Or এখানে তুমি একটা gas syringe দিতে পারো, so that you can see how the gas is coming out and what is the volume of gas. So a gas syringe, say, right, calibrated. So what is the, how vigorous the reaction is, you can find. So time taken to collect the hydrogen gas, whatever amount it is, from that, say তোমার হচ্ছে 10 সেকেন্ড লাগছে 10 cm cube volume of hydrogen collect করতে. So you are getting a message যে how vigorous the reaction is. So তোমার 5 seconds লাগছে, so the reaction is more vigorous, you will understand, right? Do you get my point? And you can count the bubbles even. If the reaction is slow, you can see bubbles are coming out, and you can count in 1 minute how many bubbles are coming out. So this is another way to know the rate of your reaction. So in that way, you can categorize the reactivity of different metals. But as I said, reaction is one: metal plus steam, metal oxide, and hydrogen gas. That's it. So again, zinc and water, zinc oxide and hydrogen gas, iron and water, iron oxide and hydrogen gas. You see, they wrote Fe3O4. This is basically a complicated structure. It's basically FeO and Fe2O3 together. That's why it is Fe3O4, because iron has 2 oxidation states. One is iron 2 plus, this one is 2 plus, and this one is 3 plus. That's why we have different formula. If you're confused, we can discuss later on. Right. Activity we'll do later on, not now. After completing calculation part, we'll do that. Right. Next point, metal and acid I have discussed. Number 3, metal and acid. So salt and hydrogen. Salt, potassium chloride, sodium chloride, lithium chloride, calcium chloride, magnesium chloride, all are salt. So if you give dilute sulfuric acid, you are getting metal sulfate. If you give hydrochloric acid, you are getting metal chloride, and hydrogen gas is common in all these reactions. Right? So a pattern, you see, try to follow the pattern. And as I say, these are all spelling rule for my compounds. So if you don't know the spelling rule, you should not start these sentences. These are chemical sentences, I said earlier, right? So to be English sentence likhar age, you must know the spelling rule of all the words. And what I'm giving is a grammatical structure, right? Subject plus verb plus predicate, right? I'm giving a grammatical structure. So when we will discuss grammatical structure, you should not ask me what is the spelling rule, because spelling rule we have discussed, and we have developed the language. We have given you alphabets. These are all alphabets. From these words are made, and for these words we have specific spelling rule, what we have discussed already. Now we are giving you sentences and their grammatical structure, so that you can put all these words in that grammatical frame in order to make a chemical sentence. You get my point? So if you have any lag back, then go back, complete those things. If you need help, then take my help, but not in the class. right? For students, those who have problem, আমাদের ওই যে lesson 1 to lesson 10 হচ্ছে ভিডিও করা আছে, ওইখানে আমরা ওই গ্রামাটিক্যাল স্ট্রাকচার গুলোকে আমরা ডিজাইন গুলো করছি, ওগুলা ওই these videos you need to see. Okay, now see, magnesium and sulfuric acid, magnesium sulfate and hydrogen, aluminum and hydrochloric acid, aluminum chloride and hydrogen, they are balancing the reaction, right? And there are some